Let's discuss the question number 17th from test 3. It is from thermodynamics. And let's read the question. So air leaks into an initially evacuated tank. So you have an evacuated tank where initial pressure is 0 and air actually goes into this at constant mass flow rate m dot, which is given as 0.004 kg per second, and the volume of this tank is 5 meter cube. Determine the pressure in the tank after 1 minute. So after 1 minute of air leaking into the tank, what is the pressure that is developed in the tank, and assuming that temperature remains constant at 25 degree centigrade. Okay, so now so let's consider a time t where the pressure inside the tank is P. Pressure inside the tank is P. Okay, so now I can write at that point of time, I can use the ideal gas equation, Pb is equal to mRT. Okay, now in time, in the next t plus dt, say this is at time t. Okay, now at time t plus dt, the pressure developed will increase, P plus Dp. The volume occupied will be m only, because the entire gas at any time, at any point of time, will occupy volume m. The mass will increase because some air will leak in time dt, and r is basically a gas constant, so it will be same, and temperature is anyhow constant. So from these two, I can say that my dp into v is dm into r into t, and if I divide by dt throughout, I can write dp by ds as dm by dt into rt, and dm by dt is nothing but the mass flow rate into coming into the cylinder. So this is like dp by dt into v, and this is given. M dot is given, R is given, T is given, and volume of the tank is given. So let's find out dp by dt. So M dot is 0.004 into for the air, the R value, the characteristic gas constant is 287 joules per kg Kelvin. Okay, and then the temperature is given as 25. So let's convert this into the Kelvin, which comes out to be 298 Kelvin by volume. Volume is basically your 5 meter cube. So when you calculate this, you end up getting 68.420. So now dp, because I need to find out the pressure after 1 minute, so dp is nothing but 68.420, which is a constant dt. So I need to integrate between the limits p1 and p2. Now p1 is 0 because it's initially there is vacuum, and p2 is something which I want to find. Time is 0. Let's say time is 0 when it is initially evacuated and at the start of the process, and the thing is 1 minute, so the time is 60. So this comes out to be p2 minus p1 into 68.420 into 60 seconds, and p2, so p1 is 0, so this comes out to be 68.420 into 60, and so when you evaluate this, it comes out to be 4.105 kPa. So the option is A. Thank you.